A definition, a definition, a definition. So what to do? What to do when you have a infinity in two places? Well, we're going to break it up. So with this definition, we're explaining how we are choosing to deal with this situation. So we're going to break it up into two pieces. So you choose some real number. C is a real number. You choose some real number. It doesn't matter which one. And you break the integral there. Usually we'll choose something convenient for C. Down here I'll choose 0. Okay, it's going to be a bit daft to choose like, you know, pi or some weird number. So I'm going to choose 0 down here, but you have a choice. And we end up with two pieces. Now if one of them diverges, then we just stop and declare that the overall integral diverges. Okay, you can't have a divergent plus a convergent somehow ending up being convergent. Okay, so if you find one thing that diverges, all done. We just say that the original is divergent. Now, let's try this example here. So follow the definition and break it. We'll choose 0. It's a nice simple number. Now in both cases I will introduce a limits. T goes to minus infinity, t 0. And for the second one, t is going to plus infinity, 0, t blah 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 blah. Now the antiderivative is the same, will be the same in both cases. Was that negative a half? Let's see. So mentally I'm doing the derivative. Oops. I'm covering it so I can't see it, but you can still see it. The derivative of negative x squared is negative 2x. So to turn negative 2x into this guy, I got to divide it by minus 2. So that'll work. Okay, so I'm doing a guess and check there. If you want to not do a guess and check, what you would do is substitution, u is negative x squared. In both cases. I'm using the letter T twice here. The two T's are not the same, so if you feel more comfortable using different letters, that's fine. Okay, so where was I? Continuing on up here. What do I get? I get limits. When I plug in 0, I get just negative a half, and then plus a half. And then for the second integral, I get the minus a half e to the minus t squared plus a half. I should rewrite what's happening with my limits. Here it's going to minus infinity, and here it's going to plus infinity, if I remember correctly, yes. But it doesn't matter, because the t is being squared. So it doesn't matter if t is going to plus infinity or minus infinity. In either case, it ends up positive. So let's write that down. So this is the key point here, this e to the minus t squared. When t goes to infinity or minus infinity, it doesn't really matter. You're going to get zero. So it doesn't matter if t is going to plus infinity or minus infinity. It doesn't matter if I'm here or here. In both cases, you're getting zero. So this first limit is minus a half plus 0. And then this plus here is the same as this plus here. Plus 0 plus a half. So we get these two things canceling, oddly enough, giving 0. Now, how can that possibly be? Let's make a little room up here and give a very brief sketch of this scenario we're talking about here. Okay, I got my xy axes. I'm looking at this function here. When x is negative, this thing here is negative. When x is positive, this thing here is positive. Now, what you get is something that looks like this, and there's symmetry. You have an area here, and you have an area here, and they're the same area. So they are canceling to give 0. So I get the negative a half from this guy over here, and the plus a half from this guy over here, and that's how we get the 0.